Good evening. Now, today we are going to see the design problems. So, we have first design problem. So, we have this as lecture number 12. Design a double angle continuous strut to carry a factorial load of 175 kilonewton. The length of the strut is 3 meters between the intersection, and the two angles are placed back to back on opposite side of the gusset plate. So now, as we know, we have step 1. Given data. And we have given data, that is P equal to 175 kilonewtons. Then we have given L 3000 mm. This is given intersection length between the intersection. So L effective we can consider it as 0.85 into 3000. And we have this value 2550 millimeters. And then we have angles back to back. Angles back to back on same side of gusset. Sorry, on opposite side of gusset. On opposite side of gusset plate. Now step 2. Selection of section. Now assume FCD. Assume FCD, and that is equal to 100 Newton per mm square. Generally for double angle we can go 100. Therefore area required P divided by FCD, and then we have P, we have 175 into 10 raised to 3 divided by 100. And from this we will get 1750 mm square. Then area for single angle, and that is equal to 1750 upon 2. So we have 875 millimeters square. So we have 875 millimeters square. Now we have to select angle. Select angle. Now, how we will go for this? So now if we will go to steel table, so I have IS 800, and when we are going to design and not mention, we will select equal angle. Now equal angle section. Now for this 875, so I have this section, that is equal angle section, 875 area. Here we have 8.75. So we have 8.75, 68 millimeters. So we have angle 68. Now I will check over here. Can I get the value of PD? Rough calculations we can go over here. So we have value of RYY, RXX, and RYY. So RXX we will say RZZ, and RYY we have same. So RYY equal to RZZ, and we have this is 18 millimeters. And then I can have KL upon R. So So KL we have 2550 upon 18, and then we can have this value 2550 divided by 18, it comes 141.67. And now I will just go, because we have this as built up section. So we have this 9C, and then if I will go to 9C, then I have this equal to, so we have 9C, and for 140 we can say, we have for 140, this value is 66.2. So for 140, KL by R 140, we have this value FCD, that is 66.2. And then we have PD equal to 66.2 into 2 into area we have of this section, that is 896. And then this value comes 66.2 into 2 into 896. It comes 118 and less than 175. So this, though we have considered accordingly, is not satisfying. Reason, we have assumed value as 100 and value actual coming is 66.2. Then we can go on higher section, or you can consider this at 80, automatically section will be higher. And now I will consider angle 70, 78. So angle 70, 78. Then I will get area of this is 1068, 70, 78, 1060. Now we have KL upon R. So we have value of RYY equal to RZZ 21.8. So we have this as 2550 upon 21.8. So 2550 upon 21.8, 117. So 116.97. So I will consider 120, and I have value for 120, that comes 83.7. So for 120, 83.7. And we can have PD. This you have to go rough. So we have 2 into 1060 into 83.7 and 2 into 1060 into 83.7, and this comes 177. So is greater than 175, and therefore okay. So we will select, so we can write. So this all work you have to go in rough. And that is expected in exam. If your section is not satisfied, you will write it, but not expected. And therefore I will now write here, select section, select angle 70, 78 millimeters. Then we have step 3. Buckling class. Buckling class. Classification we will not go for, because we have built up section and we do not have for built up section. So buckling class we have, and buckling class for built up member is C. Built up member, because we have 2 angles, and for built up member we have class C, and therefore we have to use 9C table. Now we have step 4, design compressive stress. design compressive stress. And now we will go KL upon R. Actually select 70, 78 and then we have properties. Area we have 1060 millimeters square and RYY equal to RZZ and that value we have 21.2 millimeters. And therefore we will have now KL upon R is 2550 upon R is 21.2 and this value comes 120.28. So 2550 divided by 21.2, 120.28. And now we can this consider actually, so we have KL upon R and FCD. So we have this as 120 and 130. We have value for 120. So FY 250. So we have this value 120, 83.7 and 74.3. So we have 83.7 and then 74.3. And from this we will get FCD equal to 83.7 minus 83.7 minus 74.3 divided by 10 multiply by base we have taken 120. So we have 120.28 minus 120. And from this we will get value of FCD and that is 83.7 minus 74.3 divided by 10 multiplied by 0.28 and plus 83.7, 83.44. So we have 83.44 Newton per mm square. And last step we have step 5, design compressive strength. Design compressive strength. And then we have this equal to PD equal to AE into FCD. AE we have 2 into 1060 multiplied by 83.44. And we will get this value equal to 176.89 into 10 raised to 3 Newton, which is equal to 176.89 kilonewton greater than 175 kilonewton. Therefore, safe. Provide two angles 70, 78 millimeters. So likewise, we have to solve the problems, that is design of a double angle section. So now we will stop here only. Thank you.